Hi, this is the YouTube channel for Math Contest Go Go Go. What I want to do for this channel is to build a platform for math lovers in order to make them discuss about different kinds of math problems. I will update a video about challenging problems every day. If you would like, please subscribe below. Okay. Hello. This week we are going to talk about related rates problem and the integral. So, to talk about related rates, it is how the basic step of doing related rates is that you list out the formulas and plug in values. Okay, we are going to give a problem. Let me think about this. Okay. So I'm just going to show you about how to do the problem like this. So it is asking you when radius is equals to 50 centimeters, how fast is volume changing if radius is decreasing at 5 centimeters per second? So in this case, we know that the formula for this here is r squared, r cubed, right? So first step is get the derivative. dv dt. So it is different from the what's that called? This is now you need to add the d something dt at every single constant. So you add this and you need to change this. See? So you make a derivative here. And you have to add the dr dt also at here. So it's 3r squared actually. So it is 4 pi r squared times dv dt. So this, what does this mean? This means the change of the volume. So you should also include this as change of the radius. So we need to find the change of the volume when the change of the radius is negative 5 centimeters and the volume is 50. So now what you need to do is you only need to plug in the values, 50 and negative 5. 20 is 2050 times negative 10 pi. And here is the result of dv divided by dt. So let's repeat the steps again. First, get the derivative. Second, use the implicit differentiation way, but you need to add the value, the d something, d something, everywhere. The third step is you just plug in the value. Done. Let me think about another problem. Okay. So given this, the sides of the squares are growing at a speed of 2 centimeters per sec. How fast is the diagonal changing? So we know that the diagonal formula, the diagonal is this. Get the diagonal formula here. Now we restate that so we know that we add the dx dt and this diagonal dt is equals to negative 2 this times 1. So in here we get the change of the, what's that called? The size of the square is 2. And here you get the result, which is 2 times root 2. Done. So this is just how easy the related rates is. The next step, integral. To calculate integral, we first need to talk about Riemann sum, the ways to approximate. There are three different Riemann sum, which is left Riemann sum, middle Riemann sum, and right Riemann sum. The middle Riemann sum is the most accurate one compared to the left and right. So let's give you a function. It is looking like this, right? So how Riemann sum works is that draw a square at right. See, with the right at the end. If it's right Riemann sum, you draw at the point where the middle of the here is the equation, the graph is. So you see how different is right, middle, and left. I'm going to give you a more concise graph so it is more easy to get it. The right Riemann sum, at all Riemann sum should, it's not true that it should have a degree unit of 1, but mostly you just do with the unit of 1. This is how we do it through the right Riemann sum. This is how we do it through the middle Riemann sum. And this is how we do it through the left Riemann sum. You're able to see the accuracy of it. And you add up all parts you have estimated. This. But for right, you need to add up this. For middle, you need to add up this. For left, you need to add up this. So this is how we do Riemann sum. Let's do it on graph. We ask you to calculate, approximate it through Riemann sum with steps of 4. Right Riemann sum, remember, at the interval 4 to 12. You see, so to calculate it, what you need to do is you only need to calculate this. Four steps. What? Sorry. It should be like this. So you only need to calculate this and this. A squared plus 3/8. Done. So this is how the Riemann sum works. Now we are going to talk about integrals. How integrals working is that on the first, the no derivative graph, the integral of this is this. This is calculated by graphing. So now we are going to talk about the integral. So what is integral? Integral has a definition about what I say. It also means that it also has antiderivative meaning. So x, y, right? Y is the ending point. X is the starting point. Ax is the function it is going through the integral process. Example here. Find this by graphing. So it is required to calculate the bottom of the function, the graph. And here, do not just 3 plus 6 plus 9. Remember, this is different. These two are different. Don't get these two mixed up. So this is calculate the bottom of this, and you get this is 7. So it's 24 times 7 divided by 2. Lastly, antiderivative. So there are two anti-derivatives. So there are two laws. One is, this is definitely equals to this. The first law of the fundamental theorem of calculus. The second law is function BA is equal to FB minus FA, which FA means the antiderivative of the function at the value of B. Okay, so these are the two basic laws of the integral. And here, this is the end of this film. In fact, problems, they have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!